What should procurement teams verify before choosing how to evaluate a 5-in-1 Wi-Fi weather station for institutional environmental monitoring? The answer is not just speed. Buyers need to check whether the solution fits real production targets, delivers stable data, and reduces downstream risk for quality control, maintenance, and supplier coordination. This walkthrough focuses on the practical evidence a buyer should request before moving forward with a purchase decision. A 5-factor checklist compares 5 core measurements, 150-meter RF planning, and 3 platform paths for institutional monitoring. Site-level weather data for smarter institutional decisions. Institutions rarely buy a weather station for curiosity alone. A school may need a teaching station that records the local difference between a shaded courtyard and an open field. A research group may need repeatable rainfall and wind observations before interpreting soil, plant, or air quality data. A facility team may need local wind and rain evidence before deciding whether outdoor events, roof inspections, or drainage checks can proceed. In each case, the useful question is not whether a weather station has many features. The useful question is whether its 5 measurements, connection method, and installation evidence support the decisions the institution must make. A 5-in-1 Wi-Fi weather station is best understood as a compact site-level monitoring system. The typical core set includes temperature, humidity, wind speed, wind direction, and rainfall. When paired with Wi-Fi upload and cloud platform support, the system can move beyond a local console and become a shared data point for teachers, technicians, researchers, facility managers, or procurement teams. The NIL Electronics C6071A with C3136A outdoor sensor is a useful example because its product page identifies a 5-in-1 sensor, 150-meter RF transmission under suitable conditions, Wi-Fi time synchronization, and publishing support for Weather Underground, Weather Cloud, and ProWeatherLive. 1. The gap between public forecasts and site-level conditions. Public weather forecasts are built for broad geographic service. Institutional decisions often depend on conditions at one campus, greenhouse, building complex, garden plot, or field site. A forecast may report moderate rain for a city, while one part of a campus receives runoff from a slope and another remains dry. A wind estimate at an airport station may not describe gusts around a sports field, roof edge, or open agricultural plot. For local monitoring, representativeness is as important as the product category printed on the box. 2 Wi-Fi measurements can be enough for many projects. The 5-in-1 format is practical because the 5 core variables explain many operational and educational questions. Temperature and humidity help describe thermal comfort, storage risk, plant stress, and environmental trends. Wind speed and direction help interpret outdoor safety, drift risk, and site exposure. Rainfall supports drainage, irrigation, and field event planning. A strong buying decision depends on more than a good brochure. Teams should compare measurement range, repeatability, calibration method, sample preparation requirements, maintenance support, and evidence from real plant use. When those checks are completed before purchase, the business can reduce retesting, avoid production delays, and choose equipment with more confidence.